All right, we're live. Here we are, 2020 again. Same as yesterday. Still 2020. We're looking at stretches and compressions. We're gonna get very familiar with these graphs in 2 or 3 units. I'm gonna use these though to demonstrate some stretches and compressions. These are just really good graphs to see it because they're cyclical in nature. So we'll do it on Desmos, and then we'll make some conclusions. So I don't think you need to sketch them. I think we just need to watch this. So here we go. Here's y equals sine x. So there it is in red. Maybe I'll zoom in just a touch. No, I'll zoom out. That's good. So this graph goes from 0 to 2 pi. And like I said, you'll see it a lot, but there's one full cycle. So from 0, what's 2 times pi? Pi is like 3.14. So you see it's 2, 4, 6, and it's just a little bit past 6, like 6.28. So that's one full cycle, then it repeats. Okay, so if you look at the first one in the notes, it's y equal 3 times sine x. Okay, so yesterday we were looking at reflections, right? So we had maybe like negative f of x. And what does that do? That causes it to flip over the x or y axis. The x-axis. So now I mentioned, well, like you can put a number there, and before we were just multiplying by negative 1. Now watch what happens when we put a 3 in front of there. So I'll leave the original one up there. Now let's go y equal 3 sine x. So the blue graph is the new one. Okay, now this height is 1. Now it's at 3. This height was negative 1, now it's at negative 3. 0 stayed there. Anything on 0 stayed there. So what do you think's happening when I go 3 sine x to the y values? Multiplying the y values by 3. Very, very good. So what if we do another one? What if I change this to, well, let's test our theory. So if I go 2, that point here at 1 is now at 2. Yeah, so that seems to work. What if we did 1/2? So 1/2, not times 2, but there we go. So if I go 1/2 sine x, so the blue graph is the new one, and yeah, someone said compressed. So that point at 1 went down to 1/2. This one at negative 1 went up to negative 1/2. You guys see that? Okay, so if it's a whole number, it seems like we just multiply the y values by that and we get a graph that expands. Usually we call it like a vertical stretch. If it's a number between 0 and 1, you're going to see it compressing. But in every case, you're just multiplying your y values by that number. Okay? Let me throw in a negative in there. So we'll go back to 2, and then if I throw a negative in front, see how it reflected? I can do you one even better. Well, I guess it doesn't like the brackets. There we go. If I just throw a negative 1, so we see that it just reflected, so the blue graph is the new one, it just reflected over. Okay, and that's what we did yesterday. So you're still multiplying by negative 1. You can certainly do both. Okay, so I can take my 3 sine x and I can throw a negative in front of the 3, so it's a reflection over the x-axis and a stretch by a factor of 3. So in our notes, we have that summarized for you here. You might want to get this title in, I'm not sure. Oh, you do? Oh, excellent. Okay, so we'll just quickly run through it just to read it one time. But yeah, we generally, this is the formula we'll use, so we'll call that number A. And if A is greater than 1, we have a vertical stretch by a factor of A. If it's between 0 and 1, so some fractional number, it's a vertical compression by a factor of A. And if it's less than 0, that's going to be a reflection in the x-axis as well as a stretch or compression. Right? So if it's like negative 3, it would be a stretch and a reflection. If it was negative 1/3, it would be a compression and a reflection over the x-axis. At the end of the day, what you're going to do for the y values is you're just going to multiply all your y values in f of x by a. So a point that's xy becomes becomes x comma ay. Are we clear? Good. Easiest three calculus class, you know. Pick that math book. You look worried over there, Jack. All right. All right. Everyone's good then? Yeah? Yeah? Yep. No questions? Excellent. You guys are so smart. Go ahead and let's try a question. Sure. Really quick. It's not my favorite looking shape. It's not bright enough.
Big enough.
Well, I don't know, I can stretch it out a bit.
What? What are you doing?
Well, you said you want the graph bigger.
The grid bigger.
Well, I can't do that.
No, you get what I mean.
I do. Okay, let's do it. Do it in red. Alright, well, here's the graph of y equals g of x. So, you know, generally they'll give you a couple points. In this case, they don't because this is from a different textbook. But, you know, we might have something like that. Put some arrows on there. So you pick a couple key points, and then you can do the transformation. So we're going to take points that are x, y on our original function, and we will make them do this. So this is going to be, two things are happening. It's going to reflect over the x-axis, and we're multiplying all the y values by 3, so we're going to see a vertical stretch. Okay, so in words, because they'll say, sometimes they could say it in words, they'll say, we have vertical stretch by a factor of 3 and a reflection over the x-axis. So like I said yesterday, sometimes they'll just describe it to you in words. So they'll be like, take this graph and do this. Or they'll give you the formula. So I'm just going to erase that because it's kind of in the way of my, it's going to be in the way of my graph, I think. So everybody got that down? Because I'm going to erase it. 3. No? 2. I see people writing madly, so I'll wait. Here, I'll start writing the points over here. So what I think we might want to do is if you just write down these points, just for this one example maybe, we got -2 for x and -3 for y. So if you want, you can make a neat little table, and then we got, you know, -1, 0, and we got 0, -1, and then we got 1, 0, and then we got this point again, but it's +2, -3. Okay, what I like to do is I like to write what happens to the point. So no change in the x value, but the y value is going to be -3y. So that's the new graph. And, you know, maybe I'll do it in blue or something. Okay, so you're just going to take all those points. X values aren't changing. It's going to recopy all the x values. It's just the y value, just going to multiply it by -3. So you're going to get +9, 0, -1 times -3 is +3. You're going to get 0 again, and then +9. There. So anything where y equals 0, that's going to stay there, right? So those will stay there. This one here jumps up to 3. This one here at -2, -3 is going to jump up. It's going to be past our graph. So what I'm going to do is, well, first of all, I need to erase this writing. I'm just going to sketch it. They'll always give you enough room on yours, but you'll just put a dot up here and we'll label it. I'll put a dot up here and we'll label it. So that's going to be the point 2, 9 and the point 2, -9. Okay? So now you have enough. Connect your dots from left to right and you won't make a mistake. There. Done.
So -2, 9.
Huh?
-2, 9.
-2, 9. Oh, +9. Yeah, sorry.
-2.
Yes, I messed up where my negative was. -2, 9. Thank you. I was just thinking about domain and range, which is one thing they're asking us. So just like how we noticed the other day, like whatever transformation we do, so it's on our y value, so it's going to be affecting our range. The domain is still x element of the reals, but the new range, so here's the old range. What's the old range? Look at the original function. So the old range was from 0 down. So you could write y less than or equal to 0, y element of the real. The new range for the new function, well, what is it? Yeah, so because of that reflection and it flipping over, so it doesn't quite work in this case. You just multiply it like that. To do that, you need to write it in this format. I messed up. If you write it in this format, you know, that might work. Right? This is negative infinity to 0. I guess it kind of makes sense. Like if you multiply negative infinity by negative 3, it's going to get positive infinity. Right? So the new range would be 0 to infinity. Right? You always have to write the smallest one first. So sometimes when you do a reflection or you have a negative, it changes the order of them, right? Or you could write it as saying y greater than or equal to 0, y element of the reals. Both notations are fine. They do tend to use this notation more on the exam, but they will occasionally use that one. So, up to you. Great. I have another one we can try. Let's see why not. Let's try it. So I'm going to do a little bit less work on this one. Just add in the little arrows. Should have the little arrows on there, meaning that it goes on forever. So this is a fractional one. So we're going to multiply all the y values by negative a quarter. And I'm just going to try to do the work directly on here. So, you know, this would be a good point to pick. Be careful of the scale. It's going up by 2s. Okay. So I'm going to choose this point because it's convenient because it's 4. And that might be enough. I could choose this one here as well, the negative 8 and the positive 8. Okay, so that point 0, well, that's not going to change. Right? 0 times anything is 0. So that stays there. But the point 4 for y, when you multiply it by a quarter, sorry, is it negative a quarter or just a quarter? Negative a quarter. When you multiply it by negative a quarter, you're going to get negative 1. Right? And we're expecting that because this thing's going to flip over the x-axis because of the negative. All right? Over here, same thing. Going to get negative 1. This point here at 8 is going to become negative 2. Oh, remember the scale, It's going up by 2s. Yeah, so this is negative. Oh. What am I doing here? Maybe we should write it down. 0.4 for x and 4 for y. If we just go x and 1/4 y. You guys agree with that? Yeah, okay. So I'm putting my dots in the wrong places. So if you're kind of like me, kind of prone to errors, like I know that I am, so I'll make tables, I'll do things like that. But yeah, no, we're actually here. And the y values, are they also going up by 2? It looks like it, eh? So this is negative 2 right here. So I put it right there at negative 1. And then this point's going to go here. The point 8 is going to become negative 2 for y. It's going to stay here for x. There it is. There we go. So it's going to look something like this. Now excuse my horrible crooked line. You guys will want to bring a ruler. Okay. Any questions? What about the new domain and range? Did the domain change? Nope. Still x element of the reals. And we expected that for it to be the same. But the range, of course, did. So it used to be greater than or equal to 0. Now it's less than or equal to 0. So you can say y less than or equal to 0, comma, y is an element of the reals. Perfect. Okay. Everybody's cool with that. We're going to move on to the transformation of the x variable. So these ones are called vertical compressions and stretches. The one for the x variable, so those are horizontal stretches and compressions. Okay. So we're not going to use our graphing calculator. We're going to go back to Desmos, and we're going to try sketching, or we're going to try drawing some of these. So this is the original one. And then just notice the placement of the numbers. So it's right beside the x variable. It's multiplying the x variable in all these cases. So we'll take a look and see what happens when we do those ones. So the red line is our original y equals sine x. And the first one that we were going to do was sine of 2x. So in the brackets, we're going to go sine of 2x. And it's the blue graph. And I can zoom in a bit here. So let's see, the original function, maybe zoom out a bit. Can you guys see what's going on? So you're focusing on the x variable. If you guys can see that. So the original function, it was pi over 2, pi divided by 2. Now it's pi over 4, and we did 2x. Anybody can take a stab at what's going on there? Yeah, it's some kind of a compression for sure. Yeah, definitely. Horizontal compression. So it's like the x values are becoming more frequent. Look how many waves we got on the red function. Like, you know, we got 1, 2, 3 peaks. Now we have 1, 2, 3, 4, 5, 6 peaks that I can see. So the peaks have doubled. So we got a 2 here doubling. The peaks have doubled. What happened is somebody really strong came and smushed it together almost, right? And that's why we call it a compression. Okay? So the x value here is going over here, so it's becoming half the distance. So then the next closest x value becomes half the distance. So you get more points. Does that make sense? So it's kind of the opposite effect. It's like, well, not really. I guess it's a doubling of the x values. You can think of it that way. But what we're actually doing to the x values is multiplying by 2 or by a half. By a half. Yeah, by a half. So that pi over 2 is now pi over 4. Yes. I can show you another one. What if I threw a 3 here? So what would we be expecting? A tripling of the peaks? Yeah, check it out. A bit of 4. Starting to get dizzy. 5. Anxiety going up. Chen. Chen's heartbeat. Oh, she's flatlining. Well, I got rid of the X. That's why that happened. Yeah. Anxiety, right? English class, math class, geography class. Demiral's sick. Okay. All right. None of you guys are having it today. Fine. All good? Okay. Let's try the next one. What do we got? Oh, well, 5x. Yeah. Well, I did a bunch of them, so we saw that. Let's do a fraction in here. So let's make a prediction since we're so smart. I'm going to put it in as 0.5 instead of a half. But are we expecting less peaks or more peaks? Less. And let's predict what's going to happen to the x values. Are we multiplying by a half or are we multiplying by 2? 2. Let's see. So the blue line is the new one. So as predicted, less peaks. We went from 3 to 1. I think it was a little confused soon, but let's track a couple points. It'll be harder to track points, but yeah, I can guarantee you what's happening is that we're multiplying by 2. Yeah. So this point came from there. So this used to be pi over 2. Now it's pi, because pi over 2 times 2 is pi. So that's what happens. So it's like it's getting stretched out. It's getting stretched out. So our conclusions, after seeing all that, by the way, we call that value b. So remember, we are going to be, I'm just going to wait for your chatter, I guess, to diagram. Jack, you're missing some of your butt. Yeah, when we put this all together, we're going to use those letters that we've been using, like A, B, C, D, or whatever. So for this one, we call this b. And what happens to an original point, x, y, is you go x divided by b. Right? So you guys notice it had the opposite effect. Okay, so if it was a 2, you're actually dividing the x values by 2. Alright? So if b is between 0 and 1, it's going to result in a stretch by a factor of 1 over b. If it's greater than 1, it's going to result in a compression by a factor of 1 over b. I threw this one in, if it's less than 0, then there's going to be a reflection in the y-axis as well as a stretch or compression. Okay? Questions? The most important thing is this. Now, I really hate the language they use around it. The language they use about a stretch by a factor of 1 over b, I believe is the opposite of what we were calling it. But on the exam, there's no real consensus in the math world about the language we use for horizontal stretches and compressions. So some textbooks use the language we did, but on the grade 12 provincial exam, I believe they use the language I have there. So they say that if it's between 0 and 1, so like this one that we just had, they call it a stretch. Yeah, no, I think that's what we call it. But it's by a factor of 1 over b. That's the thing that's different. Okay? So if it's a 0.5, you would say by a factor of 2. Because you go 1 over b. Is that making sense?
Yeah.
Right? So if you have sine 1/2 x like the one we have on the board. If we're talking about it in words, we say it's a horizontal stretch. We agree on that. The red line, it's like it got, or sorry, the blue line, it's like it got stretched out. But you don't say the b value, you say what the 1 over b value is. So 1 divided by half is 2. Okay? So that's easy enough to remember. Okay, let's try some questions. So first we'll just try moving a point around. So we're going to take that point -4, 2, and in each case you're going to do what it says. So, oh, I think I spoiled it here already. I'm not sure. Do you guys have that in blue already?
Yeah.
Oh, okay. Just trying to save you some time. But yeah, this is going to be multiplying the y value by 3. So the x value stays the same. The y value becomes 6. We got -4, 6. This one here, it's in the brackets on the x, so that b value is 2, but you go 1 over b, and that's what you multiply x by. So it's going to be dividing the x value by 2. Okay, you can also think of it as multiplying by the reciprocal. So you're going to get -2. Ooh. Now, if it's a third, you're going to be dividing the x value by a third or multiplying by 3, right? Does that make sense?
Yeah.
Right? It's always 1 over b. So, take that x value, multiply by 3, you get -12, 2. Now this one, it looks a little different. It's the same exact effect. So sometimes they can put it like that, but they also might write it as 1/4 times x. Okay, just like before. Okay, so this time we're going to multiply, it's going to write m by 4, multiply by 4 on x. So we're going to get -60. There we go. You guys want to do some other ones?
Yes.
Let's toss in a couple maybe that have both at the same time. So you can just go E, and I'll just make one up. I'm just going to go 2, and then let's go like this. I'll make up another one, F. Now, I can't get fractions very well in here, but bear with me. There. Let's try those two. Get your own answers. So for this first one, what's happening to an xy point? So what happens to x first of all? We're going to multiply by or divide by 2. Yeah, so you can divide by 2, which is the same thing as multiplying by 1/2. So I'm just going to put 0.5x. And what happens to the y value? Yeah, multiply it by 2. Okay, so our point, which was -2, 4, is going to become, oh sorry, it's -4, 2. -4, 2 is going to become -2 because I multiplied the x value by 1/2. And then 2 times 2 is 4. So that's the new point. Now for this next one, copy that. Let's see what happens to our xy point. So again, I'm messing around. We got lots of things happening here. We got -1/2 on the x value, which means that you're going to multiply your x value by -2. So you're going to go -2x. So you're going to have a reflection over the y-axis and a stretch. Okay? And the y value is getting multiplied by -1/4. So that's a really busy one. So you're going to go -0.25y. So what's your point? -4, 2. Okay? So -4 times -2 gives me +8. Now 2 times 1/4, -1/4. We're going to get -1/2. Do you guys agree? Excellent. So if you have like 4 or 5 or 6 points on a graph, you can apply that transformation easily enough. I do recommend making a table, like when you start getting the fractions and stuff. Don't do it in your head, as you guys noticed before, it can lead to some issues. So let's try a couple questions. Right away, we're going to make a table on this one. Yeah, I put everything together for today. So the amazing rule that will save us from all the stretches and compressions is basically if you have an xy point on y equal f of x, it's going to correspond to this point, x divided by b, comma a times y on this. Right, so this is everything we did today. We could easily add in yesterday's stuff and the day before, but that's what we're going to do tomorrow. Tomorrow we're going to do everything at the same time, so I'll give you a formula for that. It ends up being pretty doable, especially if you're doing the homework. Questions? Try a couple problems. So this is the first one. So we're just doing one at a time. So here's y equal f of x. And then we're going to do the graph of y equal f of negative 3x. Okay, so what I recommend is definitely make a table. We've indicated some points for you. That's what they like to do on the exam. So here we go. Definitely make a table. So have your original xy points. List them out. So this one, this one, this one, and this one. So we got -5. Be careful, the scale's going up by 2 again, isn't it? Yeah, just be very careful. So we got -6, -4, and then we got, so this will be 3, -3, 6. And then we got, again, 3, 4. And we got 6, -2. Okay, I'll do it in blue. So what's happening to that xy point? Well, we multiply the x values by -1/3. So we go -1/3 x, no change to the y value. So what are we expecting? Are we expecting a reflection?
Yeah.
Yeah, a reflection, and then I guess we'll look at the graph and see, is that going to be a stretch or a compression? Yeah, you're taking your x values and you're making them happen in 1/3 of the space. So it'll be this way rather, but yeah, it's gonna reflect and it's gonna get tighter. So compression. Compression by a factor of 1/3 or 3. Which one is it? Our notes say we say a compression by a factor of 1/b. Yeah, so the b value was -3, so we'd say by a factor of 1/3. Yeah. Just watch out, because the language is what gets most people on the exam. Yeah. Here we go. So -6 times -1/3 gives us +2. No change to the y value. -3 times -1/3 gives me +1. And then 3 times -1/3 gives me -1. No change to the y value. 6 times -1/3 is -2. So there it is. Once you have that, it does two things. If you have the right points, I'm like, great. And then if you mess it up when you graph it, it won't be as bad. You won't lose as many marks. So we got 2, -4. And then we got 1 for x and 6 for y, which is here. And then we have -1 for x and 4 for y, which is here. And then we got -2 for x, -2 for y. Watch the scale. Okay. And when you're looking at that on your graph, it's like, oh, well, what do I connect first? Remember, just go from left to right. Okay, so I'll do my best to get straight lines here. There. Does that seem reasonable? Remember, we had a reflection over the y-axis, so first this thing, flipped over and then we compressed it. So it seems to make sense, right? Like this would have gone like that and then it got compressed, so that seems right. Otherwise you sketch it and you hope for the best. Yeah, if you got the table and you didn't make any mistakes, you should be okay. So, any questions? No? Great. We'll do another one. See what we got. Yeah, you know, this one, like, I don't really do it anymore. Like, it's sort of harder than it needs to be. I don't have any good ones. I might just... So my first suggestion would be make a table. This will be the last one we do, I think. I don't want this video to get too long. I'll edit out the part where I go through the whole exam and find nothing. Yeah. That'll be a pain, but yeah, I'll do it. Yeah, I know it's just hard on the phone. It just takes forever. I know. So here's my table, my XY points. And you notice the arrow, but we'll just grab, we don't have to grab all of them. 1, 2, 3, this is 4, this is 5. I suppose we probably will end up grabbing all of them. But yeah, so 1, 2, 3, 2, perfect. Okay, so we got -5, 3, and then we got -4, 1, then we got -3, -1, and then 1, 2, 3, we got -2 for X, -3 for Y, and then we're up here at -1 for X, 2 for Y, and then we got the point 0, 0. Well, we know that point 0, 0 isn't going to change, right? But I guess we'll wait till we get there. So what's happening? My Y values are getting multiplied by 2, my X values are getting multiplied by 1/2. So we're going to go 1/2 X, 2 times Y. It's up to you how you want to do it. Now, when I divide -5 by 2, I'm just going to write -2.5. That's okay. It's going to be easier for me to draw that, right? Probably, rather than having -5 over 2. And then I'm going to have 6 for Y. This one I'm going to have, -2, 2 for Y. Then -3 times that gives me -1.5, comma, -2 times -1 gives me -2. -2 times 1/2 gives me -1. -3 times that gives me -6. And then I'm going to get -0.5, 4, and then 0, 0, well, nothing will change 0, 0. Not if we're multiplying. We could get changed if we had a vertical or horizontal shift. All right. So now just put them on the graph. I'm going to erase the numbers. I'll use blue. Happy drawing. So we got -2.5 and 6. 1, 2, 3, 4, 5. This is 6 right here. Can I move it down a little bit? Perfect. So see if you can sketch it. See if it looks like mine when you're done. 1, 2, and 1, 2, 3, 4, 5, 6. We got a dot up there. And then we got -2, 2. And then we got -1.5, -2. And then we got -1, -6. And then we got -1/2, 4. And then we got 0, 0. So let's see. We can see, just looking at the points, we can see that it's been stretched by a factor of 2 and then compressed by a factor of 1/2. Does this sort of make sense?
Yeah.
Now, I might just use the line tool on the computer to draw the line. But yeah, it's going to be basically something like this. And then we're going to pop up to there. Pop down to there. Something like that. And I can make them all blue. There. Now, what about my arrows?
Do you have one going up?
Yes, be very careful. So, there's an arrow there. There needs to be an arrow here. And over here, a discrete point. Okay? So, any changes to the domain?
Yes.
Yeah.
There was?
No, there wasn't.
No, there wasn't. You might look at it and be like, oh, but it still goes on forever and it's at an angle. So, domain is still X element of the reals. What about the range?
Yeah.
The domain, did you say question?
The range used to be -3 was the lowest, now it's -6, but it also goes up to infinity. So you could write it as lowest value first.
No, but
Isn't the
but
domain
doesn't the other
incomplete?
one also goes up to like positive?
Is the domain incomplete?
Yeah, because they
Oh,
are-
yes. I should specify, we don't go past here, right? So I should say x is less than or equal to 0, comma, x element of the reals. Yes, good point. Now, what about my range? Did I mess that up, or am I okay for that?
No, you're looking good.
I'm not sure about the mixing of the two different notations, but there's really nothing technically wrong with that. This is just, how would I say this in the other notation? Like the notation with the x and the y's.
It has to be greater than.
Right, I'd say y greater than or equal to -6. Y element of the reals, yeah. Good. Good job, guys. That was good. I think we'll leave it off there. We'll do some homework questions.